good. Okay, so my intention is just to do simple math. Any question how I came up with a 12,000 square foot at a 12,000 volt amp? Any question? The rest is typing. You guys know how to type in Excel. Any question about step number one? Step number one. Okay, step number two, small appliances. The most important thing, it becomes an opinion until you substantiate it. So this information that we have, guys, right here, this info that we have is very, very important for you. So I'm going to make delete it. Mistake. I don't know. I think there was something, but get rid of that. Can you guys see the 9,000 here? Get rid of it, will you? Scratch it. I don't know where it came from. What was the idea behind it? It's not part of the calculation. Everybody got that one? Okay, cool. What I want you guys to do is refer to the references. Everybody can see the reference for step number one. Let's go to step number. I jumped to step number 3. You guys will number them. I have step number 3. I cut step number 1. If you guys look at step number 1, these are typical. We do load calculation. Step number 1 does, step number 2 does the branch circuit calculation for you. Care less about branch circuits. So if you want to number them 1, 2, 3, 4, fine with me. I skipped number 2 because we used to do a branch circuit calculation there, and I no longer want them. So if you ask me where's step number 2, branch circuit calculation. You know what they use branch circuit calculation? You take the square foot of the building, and you divide it by, you take this number here, and divide it by the voltage, and divide it by 15 amp, and give you how many 15 amp circuit you need to do. This is the electrician do it. We are designers. I told you guys how we circuit. We don't circuit to the maximum, so we circuit it based on 5, no more than 10 outlets on one circuit. So I care less about the branch circuit calculation. Okay, step number 3. Any question guys about step number 1? Step number 1. Step number 3. Step number 3, guys, if you go, the first thing, go to the reference, please. If you go to the references, 220.52a, it will tell you small appliances, branch circuit, small appliances branch circuit, it will tell you 220.52a. If you go there, and I trust that you will, it will give you 1500 volt amp for every small appliances branch circuits. How many small appliances branch circuit do we have? How many small appliances branch circuit do we have? 2. We have 2 small appliances branch circuits for the kitchen. Minimum of 2 for the kitchen, minimum of 2 small appliances for the kitchen. The one right next to it is also give you for the laundry. The laundry circuit, you give the laundry a 15 volt amp. The same thing you give for the laundry, a 15 volt amp. Now, I want to remind you guys, where do they go in the main panel? They don't go in the main panel. They count where sizing the panel, but they don't go in the main panel. You're counting, and that's where these branch circuits, guys, count as volt amp, because the current that goes to the branch circuit is going to go through the main, to the sub panel, to the load, right? So they will be seen by the main panel. The main panel will be able to see each and every single thing in the building. Everybody's with me? The main panel is going to be able to see each and everything. Very good point. That's exactly what I'm going to be changing. That's why I lifted in a second. You're also right. So let me see. Here's what we're sizing, guys. Just to give you an idea, you're sizing a panel. 1, 2, 3, 4, 5. This is your house panel, and these will be the panels. This is apartment panel 1, 2, 3, 4. What we're sizing, guys, is we're taking these two, we're sizing them in one size, this one in another size, and the main panel is a third size. Everybody can see what we're doing? So this is number 1, this is number 2, and this is number 3. These are the sizes that we do. So the same thing Chris was asking me, the branch circuit in the largest panel, Chad, will it be seen by the main panel? Can you guys see that all the branch circuits will be seen by the main panel? Okay. I'm going to do with you guys number one, and then we'll go number two and number three. We're just going to go through number one, and number two and number three is, you're going to find it straightforward. Any question about this? This is your main panel here. Main panel feeding these 4 sub-panels and the house panel. What's my job? My job is to size the main panel and the house panels, and all the apartment panels. Cool? Everybody can see the big picture? Okay, so when we're doing number one, every single load in the building will be seen under one. Every single load in the building will be seen under one. So let's go and see what we have not accounted for. And you guys will go through the whole accounting. Okay, so we go to here. Like Chris, my friend, said, how many small appliances brand circuit do I have in the whole building? 2 for every apartment. So for a total of 8. So I need 8 apartment build, 8. So if you do 8, go to this math, guys, it takes the number that you put here, multiply it by 1500. Very simple. Any question why 8? Any question why 8? Any question why 8? Okay, because every apartment have 2 small appliances circuits, right? I have 4 apartments, 4 times 2, 8. Why? Why do we do it 8? Because we're sizing the main panel. The main panel will see all the small appliances in the whole building. Cool? Yes, sir.
What do you call the conductors coming from the main panel?
Thank you. Thank you. Let's go back here. Very good point. Very good point. Here's what we're sizing. This is, guys, this board here is called service entrance conductors by code, and this is Article 230. Article 230 talks about service entrance conductors. Cool? These conductors are service entrance conductors. These conductors, all of this, 1, 2, 3, 4, and 5, these conductors are called feeders. Feeders, and they are sized based on 215, code 215. Cool? So we're sizing feeders and feeders and service entrance conductors. We're not sizing brand circuits. We're using the brand circuits to size the feeders, but we're not sizing brand circuits. We already did the brand circuit. You guys circuit the whole building, right? Okay? Any question about this point, guys? What we're sizing? Service entrance conductors and feeders. Okay, so let's go down. Hold your horses. Okay, so that's 8 conductors, brand circuits, 1500 volt amp each. Any question, guys, about this? 8, why 8? Now, where did I get the 8 of them, guys? 2 for every circuit. It's from 220 to 52A. If you have not highlighted, what I expect you guys when you take this sheet is to take all these references, highlight them in your code book so you can refer to them. And check them. I checked them to the best of my ability. Where does it say? Chris, if you look at this 210.11C1, if you go there, it will tell you that you need a brand circuit, 2 brand circuits. You need 2 brand circuits in the kitchen. And if you go to 220 to 52A, it will tell you that you need, every brand circuit need 1500 volt amp. So why do I have 2 references here? This one, 210.11C1, it will tell you need 2 brand circuits. This one, 220.52A, it will tell you every brand circuit need a 1500 volt amp. Any question about that? Any question, guys, about this? Cool. Let's go to the second one. Brand circuit laundry. The same reference, guys, that you're looking at right in here. The same reference. It talks about the laundry need 1 brand circuit, and for that particular brand circuit, if you go to 220.52B, it will tell you that laundry need a 1500 volt amp. Okay, so let's go right under the laundry. How many laundry circuits do we have? Now, let's have a moment of truth here. How many laundry circuits we have in the building? Do we have laundry inside the apartments? No. Do we have laundry, common laundry for the whole building? Yes. Do you remember how many washing machines do we have? 2 washing machines. So to washing machine, I'm gonna assign as a one circuit for every washing machine. So how many laundry circuits do I have for the whole building? 2. Do I have, if every apartment has its own laundry area, so what do you need to do? Account for 4. So I'm gonna go turn this into 2. Everybody knows why 2. Everybody knows why 2. Because the whole building, the apartments do not have a laundry circuit. They have a common laundry area. The common laundry area has 2 washing machines. These 2 washing machines, I'm assigning a 20 amp circuit for each one of them. So these are my 2 laundry circuits based on my design. So I gave him 2 circuits, 1500 volt amp for a total of 3000. Questions? Any question, guys, about the laundry branch circuit? Any question about the laundry branch circuit? Can I ask you guys, you did the load calculation with Gary for a house, right?
Yeah.
Okay, so these are not completely foreign to you, the numbers, but please check the answers too. Okay, cool? Everybody's cool with that one? Let's go to the next step. Now, if you go through the code, guys, it will tell you the laundry. Then you go to this step, and it says step number 5. And by the way, Phil, my friend, you can do it as many steps as different way, but as long as you go follow the logic. Then step number 5, it adds everything that we have done. It adds the small appliances circuit and the laundry and the volt amp for all the light and receptacle. Adds them up. So Oladipo, if you double click on this cell, here's what you're going to find in math. Can you guys see? It says sum. It's adding a couple of things. If you're familiar with Excel, can you guys see the highlighted cells that's adding them? It's adding the 1200, the 12,000, the 12,000, and the 3,000 together. Everybody knows if you want to know where the math is coming, either you can see it right at the top here. So, Rob, my friend, if you're confused with the math, I know this simple math, please write to yourself a note. This is what this cell is doing, is adding them together. Okay, enter to get us there. Any question? We added the volt amp of the 2 small appliances circuit, the laundry circuit, and the volt amp for lights and general lighting and general purpose receptacle. Typical, you guys did that for the house. What's the difference here? We have an apartment. What's the difference? A square foot of the whole apartment multiplied by 2 because it's a 2-story building, as well as we have more branch circuits for the kitchen and we have more branch circuits for the laundry. That's the only difference. Ashley, my friend, does it make sense? Okay. Now,
Are you following the format on the code example? Is that
for the most part, for this one, for the commercial, we diverge for the most part. Yep. There's an example in the code book as you when you did it with Gary that was followed. We're following kind of the same format. Okay. Any question about 27,000? Where we come up with 27,000? Any question about that? Okay, let's go to step number 6. Step number 6, guys, I want you to go please to 220.42. If you go to 220.42, article 220.42, and table 220.42, it says, article 220.42, it says, if you have, how many? General lighting, small appliances, okay. I'm sorry, table 220.42, it says you can apply a demand factor on general, lighting circuit, general receptacle, general light, as well as small appliances circuit laundry. You can apply demand. Here's what the demand is. If you guys go to table 220.42, it tells you the first 3,000 are sacred cow, put them aside. Everything else up to 120,000 volt, cut them by, what was my multiplier here? 35. Okay, subtract, and up to the remainder, up to 12,000, cut them by 35. Do we have 12,000? Do we reach even 12,000? 120,000. Do we have 120,000? You don't even use the third step. So let me remind you, this is derating the lighting and the small appliances circuits, the laundry circuits, and the general purpose receptacle circuits. By code, you are allowed to derate them. How do we derate them? Take the first 3, put them aside. Anything higher than 3,000, you're going to cut them by 35, and then add them. So here's what I did. You take the first 3. These are sacred cow. Then you take the 3. Can you guys see this cell is doing? And you can do it in any way. I don't care about the cell. The first 3, left them alone. And then I took my cell here, 27,000, subtract 3 from it, and that's what I get here, 24. And then I multiply the 24 by point here, carried it here, multiply it by 0.35, and carry it to this cell, and add the 2 cells together. Add the 2 cells together. Any question, guys? Let's do that. So here's, if you look, this is just a 3,000. Carry the 3,000 in this cell. Subtract from here. This is D3, which is 2,700 minus the 3,000. Then you take the leftover and multiply the leftover by 35%. And that's what we did the math right in here. We did the leftover, 2,400, multiplied by 0.35, gave me 11,000. Okay, and what do you do with the 2? Add them up. You add them up. Everybody can see what we did here? This is typical in the code. You guys did the same thing and for the house. The only thing different here is a bigger apartment. Any question? Any question about this? How to use it? The first 3,000, leave them alone. Take the total, subtract 3,000 from it. And then the answer multiplied by 35. And then add the 3,000 to the answer that you got after you subtract the 3,000 multiplied by 35. Any question about this, guys? Any question about this? Okay, now I start putting red here. Everything that you see red will be carried right through all the way down. Everything you see red, you can color it with anything else. It will be carried right through the whole system. Okay, cool. All the people. Any question up to this point, guys? All the references are right. Nick, did you check them? 220.42. Yep. When you guys have a chance, check them. 220.42. Okay. Any question about this step? This step, the 11,400. This is what you're going to carry as a demand load for the small appliances, the laundry, and the general purpose and general light outlets. Done. Now, Oladipo, if you're not familiar with Excel, guys, I know a lot of you are experts in Excel. If you're not familiar with Excel, this cell, the red cell, it's going to override everything else above it. So you're going to carry only the red cell. That's the total for all these steps. The demanded total, not just the total, the demanded total. And it makes a lot of sense as we go down. Let me go close my email. Any question about this? So what's my expectation, guys, from you is to do an Excel sheet similar to this, or better. Similar or better. I have no problem with making it better. Minimum is what I'm showing you. Anybody is wondering about any of these cells, how we came up with? Look at this cell, if you double click on it, this actually cell equal this cell. So just to make it arrangement, to make it look like this, I made this cell equal this cell in math. Okay, cool. We're done. Yes, sir.
So in line, where it says line 5, row B there, where we multiply subtract the 3,000.
Yep.
We got 24,000.
Yep.
If that number was, so let's just say we change our numbers, if that ended up being 3,000.
Yep.
Do we multiply by 100% then?
No. Yes. Yes. If it's 100,000, then you multiply by 100%. Yep, absolutely. Very good point. And I don't have the math here, but say when you subtract these, if that number was less than 3,000, then these steps here, you wouldn't even go there. If it's this 3,000, this number will be 0, so this will be 0, and you carry the 3,000. If this is 2,700, my math doesn't do that yet. You can make the math. I care less about, you can make the math do it. If it's 2,700, that's a small amount, 2,700, then you're going to end up with negative here. But 99% of the time, you're not there because of the size and all this stuff. So you have to do a math. If you're in this situation, you have to do a math that tells you if it's negative, if it's less, if this is less than this, then stop there. Put 0 here. I don't care about this in the math. I know probably Chris, you'll be doing that routine F. I don't care. What I care about right now, 99% of the time, we're going to end up with a number here. A number here. The one that we carry is more than 3,000. Good point, though. Any question, guys? All the people? Am I going too fast? Slow down. Drink coffee. Okay, cool. Anything you see red, it's going to be carried right through for the all the way down. So let's go next. So we're done. If you guys think up to 7, we're done with all the small appliances circuit, the laundry, and the general lighting and receptacle. Completely done. Now go down to step number 7. Step number 7, ranges. And Chris, my intention is not to go back and teach you range calculation again. You guys did range calculation with Mr. Ryman. You spend enough time on it. Done. My intention to use range calculation to size the service. How many ranges do I have in the whole building? And what size? You guys have the sheet with you? You have your sheet handy? The sheet will tell you the size of the ranges that we have. So might as well do it. If you guys go to the project sheet that I gave you, I'm giving you range 1 per unit, 8,000. I have 1 range per unit, 8,000. So Nick, it doesn't take rocket science to discover if you have 4 units, how many volt amp for all the ranges put together? 8 times 4, 24,000. So what I'm writing here, I'm sorry, 32. No, it does take rocket science. 32, 1, 2, 3. Now, I'm sure Chris is going to do it differently. The way we did it here, it's not the best way. You take all your ranges in the whole building, the volt amp, and you put them as a lump sum. Okay? Everybody cool with the lump sum? Why did we do 32,000, right? 32,000. 800. We're coming. This is all your ranges put together. Yet, any question, guys, where we came up with the 3,200 or 32,000? Then you're going to go to table 250.66. Can you guys go to 250.66, please? Nick is yelling at me and said, "Go the rate chat." If you guys go to table 250.55, 220.55, 220.55, all the ranges are under which column? All my ranges are under B. Can you guys see that? All my ranges are under B. They're all. I'm not going to review how to use this table. You guys know that if your range is in A, you apply A. If your range is in B, you apply B. Otherwise, you apply C, and there's certain notes for C. I'm interested at this point of all the ranges are the same size. All of them are under B. Everybody can see it. They're all under B. And I have, how many of them do I have? I have 4. What's my derating factor? 50%. So can you guys change that 1 into 0.5? Okay. I don't know what did I do with that one. No, actually, okay, I think this is how we, the way the math is, I like to, the way the math is, this is the 8,000, and this is the number of, the number is 4 here, and this is how you do it. One more time, I like you. You put, this is, you can do it any way, guys, you can in Excel. This is one size, and this is how many of them do I have, and this is my derating factor from 220.55, and that's your total. So if you click on the total here, you can see how it took these 3 cells and multiplied them by each other, right? So you took the 8,000 multiplied by 4 because I have 4 of them, and then you went to the table 220.55, and you took the 0.5 from there, and you multiply it by them, and you end up with, what did we end up with? 1,600. Any question, guys, about this? Actually, this is better. Can you guys modify the sheet that I gave to you? The sheet that I gave to you is supposed to be a sample, not supposed to have the whole calculation, but we end up doing a calculation together here. Any question about the ranges? Oladipo, Tao, my friend? Any questions? Make straightforward? No? Okay. Just a reminder, guys, we're going to be chapter 5 and chapter 6. Chapter 9 and 10 does exactly what we're doing right now. Step-by-step load calculation for apartment building as well as for a house. I think 9 is for one and 10 is for apartment building. Step-by-step. Okay. One more time, and because I don't want to multiply, I'm going to click on this. Oops, not here. Click on this one. Can I get you guys, Jackson, my friend, to understand this is the size from what I gave you. I gave you the size. This is 4 because we have 4 of them. We're sizing the main building. 0.5 is coming from 220.55 for 4 ranges under B. And this number is coming by multiplying all of them together. Okay? Did we kill this horse? Everybody's good? Phil, my friend? William? Good? Okay, so that's step number 7. Any question about step number 7? Now, am I going to go do range calculation with you? No. You guys cover load calculation. We take the ranges and we put them in a building now. We size branch circuits for them and feeders. Any question? Any question about step number 7 before we go to step number 8? Step number 8. Step number 8, it talks about electric clothes dryers. If you guys go to Article 220.54, it refers you to table 220.54 too. Here's what this tells you for dryers. If you have electric dryers, Jackson, and if your dryer is 5K or less, 5K or if it's 5K or less, you use 5K. If your dryer is 5K kilovolt amp, 5,000 or less, you use 5,000. If it's more than 5,000, what do? You use the nameplate. Okay, so let's look at the dryer that I gave you guys. I gave you a dryer, and my dryer is sitting exactly at 5,000. Surprise, surprise, Chad. I set my dryer at 5,000. So how many dryers do I have in this whole building? 2. So here's my dryer, 2, and multiply them by here. Okay, what's my derating factor? There's derating factors for dryers. Up to 2, the derating factor. Actually, you guys should multiply this one by 1. That will be the derating factor. And if you modify this, you take this and add another multiplier, 1. Enter. So can you guys modify this? So here's what it becomes. This is the range, the dryer size, 5,000 or the nameplate. You can make the Excel does that. My intention for you guys, when you give it to me, you make this decision, not Excel. So here's a 5,000 multiplied by 2 because I have to, multiply by 1 because based on the table, up to 2, your duration, your demand factor is 100%. You go higher than 2, then you have to go pick up the demand factor, right? Everybody can see? Like if I have 3, I have to cut this number by, anybody can see that, guys? 220.56. If I have a 3, I have to cut this number by 90%, or I cut it to 90%. Any question about 220.54? 220.54. Please go to 220.54, guys. Can you? 220.54. Up to 2, no derating. 1. Higher than 2, you start using the table.
No, it starts with 5.
5. Yeah. So 1 to 4, 100%.
1 to 4 is 100%.
Yeah.
5
5 to 4.
So you guys all at the same table, and I'm at different table here.
You were talking about 220.
Yeah, 220.54. 220.54, demand factor for house electrical, you're absolutely right. 220, I was looking at different table. 220.54, up to 4, your demand factor is 1, higher than 4, 85. Thank you, sorry. Up to 4, your demand factor is 1. 1. Up to 4, your demand factor is 100%. Higher than 4, so if I have a fifth, if I have a 5 of them, I have to multiply it by 5 and multiply it by 0.8. Okay. Any question, guys, about this? We got this one, this table, 220.54. 220.54. Thank you for correcting me, Jackson. 220.54. Any question? All right, so let's go to the furnace. I have a furnace. This one is interesting. This one is very interesting. This is what we call it, Ashley, non-coincidental loads. Non-coincidental loads. For your non-coincidental loads, guys, you take the largest of two. As you know, the largest of the heat or the cool, whichever is larger. Okay, now let's go back to my building. I have heaters. If you guys look at the list here, I have my heaters, and my heaters, the only heating element that I have here is I have my heaters, and I have my AC units. My AC units, and you can do the math in it, my AC units are 4,000 volt amp each. I have 4 of them. 4,000, 4 of them. If you look at the heating element, I'm using gas to heat, so not a whole lot of volt amp when you use gas to heat. I have stairway heaters. You guys remember the stairway heaters? Swimming, coming garage stairway heater. I have coming garage stairway heater 3 kW for each. So I made the decision. If you guys, I have three stairways based on a rule. 3 times 3 is 9 kW or kvolt amp for the stairway heaters. Plus the heating element from the gas is not a whole lot. Compare this to the cooling. The cooling is 4. 4 times 4 is 16. So which one is the larger, the heating or the cooling for me? In this case. In this case is actually the, am I looking at the next table here? Network, laundry. Okay, so this number here, furnace, electric heat, this number, we should probably make another, to make it more interesting. Let's just say this. I have my cooling is 4,000. Can you guys add that one? Let's put, I think I can use this cell here. I'm going to make this cell easier. Let's take a 4,000 cooling here. And how many of them do I have? I have 4. And if you do the math in this, this should equal this multiplied by this. Can you guys modify it? Done. This is my cooling number. What's my heating number? If you guys want to go do your heating numbers, you can do your heating numbers. I know my heat, you probably should do your heating numbers. 3 times 3, 9. Which one is the larger? Obviously the 16 is a larger, so we're going to stick with the 16. We didn't do this step, but
account for the heater in the pool?
No, that's not general purpose heating. That's not general purpose heating. That's special type of heat. We'll account for it later. Yeah, it's going to be account for it later. Yeah. Huh?
It's probably run at the same time.
Yeah, but you could have. Yeah, you could have. The reason why I don't put it here, because you could be heating the cool while not heating the house, because the cool to swim, the idea is to swim in it. The water could be cooler. So they're non-coincidental load. They could be on with the heat.
I'm saying they can be on at the same time as the air too.
Yes, absolutely. Yep. That's why we don't want to drop them. We don't want to drop them. They're coming down. They're coming down. Any question, guys, about the heat and the cool?
Why did you refer to Article 440?
Article 440 talks about the HVAC equipment. And Article 440, guys, if you go to Article 440, it tells you you basically have to take the amp multiplied by the voltage to get you the volt amp for the HVAC equipment. Article 440. Okay. So I want to remind you guys, this step is kind of interesting. If you go to 220.51, Ashley, it tells you if you have heating, count all your heat at 100%. If you go to 440, Article 440 will tell you the HVAC have to be counted based on the amp multiplied by the voltage. If you go to 220.60, it tells you, oh, by the way, these are coincidental loads. They will never be running at the same time. So could you please do me a favor? Pick the largest of the two. Pick the largest of the two. Pick the largest of the two. I didn't do the pick the largest of the two, but it's so easy, guys, for you to put a 3,000 here for the heater and multiply it by 4, because I have 3. I'm sorry, 3, and make this cell equal this multiplied. Where's multiplication again? Multiplied, because 3 stairways. Yeah, these are, remember, these are just for the stairway. And you guys can see, I just added this step to compare. This is my heat. And if you want to make it clearer for you, again, this is a guide. You can make this heat, do this one as a heat right here. So here's my heater. That's the only heating element that you're going to have in this building. Now, I'm sure Chris is looking at me saying, Chad, what's about the furnace? The furnace is burning what? Gas. How about the pump of the furnace, the furnace fan? The furnace fan can work with both the heat and the cool. We're going to add it later. Does that make sense? The only heating element that we have in the whole house is really the right? Everything is gas. Gas, I care less about the gas. So here you go. Now, I'm sure Chris is going to go make a routine. And I really, if you guys want to do it perfect for me, you can make a routine where it says, this cell will say, if this, choose the largest. You can make a cell here that choose the largest of this number or this number and drop it here. We do in a commercial project. I don't care. For you guys, if you do this step, I know that this is 9,000, this is 16,000, so I have to carry it right here with the 16,000. You choose the largest. Choose the largest. And anybody knows why it's red? Because it's going to be carried downstream all the way. Any question about heating, cooling? The heating 100%, the cooling 100%. When you calculate it, compare them, choose the largest, and add it downstream. Dustin, my friend, any question about step number 9? So what I want to say, Nick, my friend, this is a little bit more than what you guys have done in the past. A little bit more, not a whole lot more. There's a few things because we're looking at a whole building. Any question?
Why do you have to pull a heater under a motor?
We'll reach it. Okay, we hold your horses until we reach that one. Okay, any question, guys, of step number 9? Okay. So step number 9, then, just to follow the format that we use in the code, add all these steps together. So what is what we did? We added, can you guys see, if I clicked on the yellow, it takes all these red, only the red cells, and add them up, which is 6, D, 7, 8, and 9. I hope the numbers are right? We added them all up. You really don't need to do that. This step's what I've done it in a commercial. We got rid of this step, but we just to follow the format in the code to add them up. Okay, any question about that? So now, moving forward, the yellow is actually a sum for everything upstream, summing everything upstream. You really, step number 10, you don't have to do it from a code point of view calculation. Any question? Any question, guys, before I go to step number 10? If I suggest, you guys probably don't need it. You really don't need it. Doesn't give you any value. We did it again to follow the format in the code, the way they do it. Okay, let's go to step number 11. So Jackson, can I get you to understand that everything that we've done so far is summed with a demand number of 53,400? Okay, so the red, forget it. Everything that we've done, later on we're going to be carrying one number, the 53,400. All right, let's go to 11. Any question about 11, guys? Look what 11 says. 11 says, list fastened-in-place appliances in addition to the electric ranges, electric dryers, all the electric ranges, we don't do them. Fastened-in-place appliances. If you guys go to 53, 220 to 53, it tells you if you have appliances fastened in place, add them up. And then after you add them up, if I think there's a table here we're going to apply at step 12. Yep, if you have more than 4, if 4 or more, if you have 4 or more, you cut them by 75%. One more time. This is again from the code. So you're going to go to the fastened in place appliances. That will be your water heater, dishwasher, food disposal, microwave. Some people, guys, put the garage door opener, a bunch of other things. These are the ones that I like to put. It's your judgment. It's an appliance. What's an appliance? Appliance is manufactured in larger quantities and sold as a bulk. That's what appliance is. So would garbage disposal, do we have garbage disposal as an appliance? Microwave, I have dishwasher, and I have heater. I don't know if we forgot anything else. Garage door opener, I like to put it on a different step with motors. Okay, so if you guys look at these, and you can do this in any way, shape, or form. So I have the water heaters, how many water heaters do I have? I have 4 of them. So I didn't make a step, but we can make a step right here. I don't like the way we done that one. So here's, we're saying 2, so I'm going to go change this one to 4 for the apartment. Dishwasher, how many dishwashers do I have? 4 of them. How many garbage disposal do I have? 4 of them. Can you guys see that? How many microwave do I have? 4 of them. I'm looking at the whole apartment. Okay, and the sizes, I think the sizes are coming from, I don't know if the sizes, garbage disposal is 1,000, right? These sizes are from the sheet that I gave you guys. And microwave is 1,000. Do I have microwave? Give you 1,000. And I gave you dishwasher 1,600, right?
No.
Dishwasher 1,600, and I gave you the water heater is 5 grand, right? Water heater 5. Okay, and then what I did. This is really not a good way to do it. It would be really nice to have another column and you put the 5,000 multiplied by 4, especially when you're going to do it. So to do this, since you guys are good with Excel, I'm adding him all the way at the bottom here. So I'm trying to see without missing too much with it. Okay. Here's what I'm going to do. I'm going to do you guys mind if I grab this in Excel and move it to this side? Okay. I moved it to one side, and right in here, I'm going to put the size of my appliances. So I'm going to put the size 5,000 so I can do them. 1,600 and 1,000. 1,000 and 1,000, right? Did I miss anything? Did I put the numbers right? When you guys work, did I miss anything, Chris? So you can come over here and make your. What I did, I shifted them slightly, and you guys can do this in Excel so easy. I can help you if you're not good. So here's what I'm going to do. The reason why I did this, then I can come over here and put equal this number multiplied by how many of them do I have? I can add another cell, as a matter of fact. In this case, 4. Enter. Right? Did I do it right? 5,000. Okay, then this one here equal. Well, actually, after that, you can grab this and you drag it, and it will drag the whole math. If you're familiar with the Excel, you drag it, it will drag the whole math. So then, if I click here, this will give me the 4 multiplied by the size in the whole tab. You guys can make it a much better than I can do here too. How's your knowledge with Excel? Good? Not you, Chris. Everybody else is good with copy and paste and all this good stuff. So you can make it, this will look actually nicer than I was showing at the beginning. You put the whole tab. If I were you, since you guys are designing from scratch, I would add another column. If I were you, I would add another column right here to tell you the truth. I'm going to get rid of these, and I'm going to, I'm going to delete. I'm going to make this one, how many of them do I have? 4. And how many of these I have? I have 4, 4, 4. So I'll drag this and make this 4. Just 4, 4, 4. Enter. And actually, I'm going to change my math here to, instead of 4, so I can enter them, multiplied by this. Enter. And then you drag this, and it will take all the math with it. Shouldn't change the math. Okay, so what I did, when I'm doing one apartment now, if I want to go now for water heater, one apartment, all I have to do is just put 1 here, and guess what? It calculates it for that particular apartment. So I have 4 here for this. You can do it any way, shape, or form. That's a nicer way, where you have the equipment, volt amp, how many equipments do you have, and their total. Can you guys modify this, the sheet that I gave you, to reflect something similar to this? Okay, so then you add them up, and this is, you can see it's just summed up, right, at the bottom. And that would be all these fastened-in-place appliances with a space, room to do that in the future, to add more. Any questions about this? Nick, is it confusing? No? Straightforward? No? Okay, so these are the appliances. So let's go to step number 12. Step number 12, and feel free to make 11 and 12 one because they're demand factor. Step number 12, guys, you go to 220.53. It will tell you if you have 4 or more, you have to cut them by 75%. Okay, so here's the number. Can you guys see that this number is carried? This number is carried from this number here. I just brought it down. Do you guys know how to bring a number from cell to cell? Equal cell A, cell B equals cell A. So equal in cell A, B, that will bring the number from A, put it in B. Right? Cool? Okay, so that's, I brought this number down and I multiplied it by 0.75. And there's some actually F here. I'm not interested in putting an F. If you guys want to put the F this, otherwise, in this case it says if equal or more than 4 multiplied by 0.75, otherwise 1. This is easy if anybody wants the routine. It will it's telling the cell if the equipments are more than 4, then multiply by 0.4 or more, multiply by 0.7. Otherwise, it multiplied by 1, which is basically no derating. If otherwise, meaning if it's less, then multiply by 1. Okay, my intention is you guys will change this number as needed. So if it's less than 4, what do? You just put it 1. And here's the number here, right? And then you multiply two numbers by each other. Is it multiplying it? In this case, it's multiplying the top here. I don't know why we multiply the top, but you can grab it from here and bring it here, and off it goes. Okay, now we don't want to do that. This number is 0.7. I think we have, because you have to compare the number, because the math. Either way, in your case, if you're entering this one, all what you have to do is take this cell, equal this cell multiplied by this cell, done. Any question? We derated that number, and why do you think we put it in red now? Because we need to carry it downstream. We need to carry that number downstream. That's a derated value. That's a derated value. So I probably should carry it downstream here. Okay. Any question about number 11 and 12? Step number 11 and step number 12? Any questions about step 11 and 12? I'm going to do 13 and give you a break. 13, if you guys 13, it says total contact load. Add everything that we have done, the demand for the small appliances, the ranges, the dryers, and the HVAC, and everything else. So if you guys look what we've done here, if you click on it, it adds, it's adding, okay, so here's so adding line 10, where's line 10? Line 10 is taking, right here. You guys see that number, 53400, and you don't have to do the math this way. It's taking the total for all the steps up to 10, adding to it line 12, which is 225, and totaling it. Really, this is worth of time. And then, can you guys see that? Line 12 with line 10, totaling these and adding them over here to carry them. Adding them to, it's basically taking the 53400 and adding the fastened-in-place appliance to it. So that number, 79200, is my total for everything up to step number 13. Do you have to do it math-wise this way? No. You can do it any way, shape, or form, as long as you account for them. I think we followed the format of the code, which is kind of jumpy a little bit. Any question, guys, about 79200? So now I'm up to 7900. Shall we have 5 minutes break and then we'll continue? Okay. All right, let's go. Let's go all the way to step. We left it, guys, at step number 13. Step number 13. Any question until step number 13, guys? Let me tell you one thing. Like Chris said, my friend, if you guys have done this in an Excel before, I don't care if you follow my steps as long as you convey the message. Here's the message. I need all the code references there, and I need all the calculation there in Excel sheet, and I also need some details. For example, like this is 0.75. I really would like to see where you got this 0.75. If you can put it somewhere. So the more details you can give me, the better. How to format it, up to you. Should like Chris, look at step number 13. I think step number 13 is worthless. Should I do step number 13 or not? It's up to you. Okay, so just to follow the format that we have, guys, any question up to 79,200 volt amp. All right, let's go to motors. I don't think did you do a motors, Chris, in the sheet that you have? Motors. Now for motors, guys, if you have motors that's not appliances, for the most part, you separately put them in a list. So Nick, my friend, I have to find it for motors, you need to go 230.50. It tells you motors at 100%. You take 125% of the largest motor plus all the full load current of all the motors. That's how we size them. And where do you find the info about motors? In Article 430. That's why I gave you two references. Okay, let's go ahead and do it. Sump pump. I have a sump pump, one sump pump, so I put my motor sump pump at 100%. I have one of them. Here's what I'm hoping, guys, you guys do. You'll put how many of them do we have? The volt amp here, and you put how many of them do you have here? One, and you make this calculation. This cell equal this cell multiplied. Where's my multiplied? By this cell, and oops, it goes. So make math out of these. And then the second one, guys, and then look what I'm going to be dragging these down and just modify them. See how in Excel, really cool, you can drag all these. So I have 1,000, 1,000, 1,000. This should be 4,000, 1, 2, 3. And this should be the sump pump. The sump pump, 3, 2, 6, 4. I'll tell you where we got the sump pump. The garage door opener should be 1127, 1127, and this should be 1,000. How many of them? The exhaust fans. How many exhaust fans do I have? Bathroom exhaust fans. I have 4 for every room, right? And how many garage door opener do I have? Garage door opener I have 4. Okay. Did I do the math right? So I just modified this to this reflect how many of these equipments do I have? What's the volt amp of the equipment? Then multiply these two together, give you that total. Did we do it right? 1, 1, right on the spot. 1, 1, 4, 1, 1, 4, 1, right? Now then these should be modified too, because I have how many exhaust fans in the bathroom do I have? I have 4. How many exhaust fan, garage door opener do I have? 4. Can you guys modify the one that I gave you? Cool? Everybody's okay with that? What's the math? The math is, if you click on it, you take this column, the volt amp, multiply with this column, the number, add it, and then add them at the bottom. Any question about this? I'm just modifying it slightly. All right, now Chris said, Chad, how would a pool heater sit with motors? That doesn't make a whole lot of sense, right? Okay, so pool heater really is not a motor, is it? So what I'm going to do, guys, and you're absolutely right, I'm going to go grab the pool heater. That probably would be an exercise in Excel. Grab the pool heater right here, because it's not a motor. Can you guys see that, everybody? The pool heater, I'm going to go cut the pool heater, and I'm going to go put it right in here, right underneath this one, and I'm going to add it, paste it. So I grabbed my pool heater and removed it from here. I'm going to go insert, and I'm going to have step, if you guys can make a step 14.2. I'm going to call this 14.2. I'm going to call it the whole area here. You guys know how to merge these cells, merge cells. Merge your wrap. So what I'm doing here, I made this cell 4.2. I'm going to call this a special equipment. Special equipment, if I spell it right. And of course, my cell here is a math cell. And delete this cell. Shift to the right. Okay. Yes. All right. So water heater. Delete. I hit that one. Delete. Shift cell to the left. Shift cell up. Enter row. Okay. Enter row. All right. Okay. So let's go and insert. Do it one more time. I hate putting this. Delete. I guess we can do 14 here. Here's 14.1 pool. Let's just do pool here, guys. And then what's the reference for this pool? And just put it separately. Put it in a separate line. But it's not the good location for it. So what I'm trying to do, let me go back. It's not really the good location for it. Go back, Chad. Go back. Chris, do you have to open that can of worm about the heater, man?
Sorry.
Okay. So for the heater, let's go see insert, if we can move an insert here, a couple of inserts, and move the heater. Okay, so I don't want a grand total. What did they do? 13. You just want to make sure we put it in the right location. No, it's not the right location because we're adding, so it should be under the other one. So I'm just going to try to create back. Okay, grand ambiguity right here. I'm actually going to put it right in here. Insert a column and insert another column. And I'm going to make a step 15. If you guys make it 15.1, any step just to stay. And I'm going to go grab my pool heater so I can be on track. Copy it. I'll delete it later on here. And I'm going to go grab it. Where did I put it? I'm going to put it right in here. Paste it. Okay, so here's my pool heater. And I need a volt amp for it here. Volt amp, and off it goes. And make sure I account for that. So I put it in red so I want to account for it. Okay, so what I did, guys, I had added my pool heater and as a separate 15.1. A heater is, you can add it separately. What's the code reference for a heater? Code reference, because you can't do anything without a code reference. You guys fixed in place appliances, electric furnace. That was 220.51, I believe. 220.51 is the reference for heater, any heater, pool heater. So my reference for this baby is going to be 220.51, right, Chris? Did you check it? 220.51. 220.50. Yeah, fixed electric space heating. Some type of fixed space heating equipment. It's different equipment. Okay. So could you please do me a favor, guys? When you design yours, just the baseboard heater, the pool heater, delete the pool heater. Okay? Everybody did that. The pool heater, delete it. Then, when you delete that, did you guys do the math? The same thing. And then what we're going to do, we're going to take the largest. This one, the code says if you have motors, you take the largest motor. So multiplied by the largest motor. You can do the math in any way, shape, or form. So I did the math in the simplest way. The largest motor for us is the largest motor was 3264. So here's what happened. If you take this cell equal, if you guys can see, this cell equal the largest motor. Now I know Chris, what's going to Chris do? You guys can make this cell max. Put equal max, open brackets, and it will look at the maximum of these numbers. Let's try that one here. Equal, close that one, see if it works. Equal, max. This is a function that looks at the maximum between all these numbers. See what it did? I'm telling it, go look at the maximum number here and drop it down there. So this cell equal max of any of these, all these numbers, max all of them, and then drop it right here, then multiply it by 20.25 and put it right in here. That will be my largest motor in the system. Yes, sir.
Just looking at like the bath and exhaust fan, there's 4 at 1,000, so you have 1,000, and then you have 4. Would you not multiply 1,000 by 4? Where do you get 2,000?
Ah, thank you. We didn't carry the math here. You good? So drag the math here. I just didn't carry math. Here you go. Now we're good. Okay, so we absolutely. So you want this times
You need to check the garage doors
number 2.
garage openers.
Garage door open. Everything. This is 100, 100, 100, 1,000.
You carried the formula, so it changed everything down a larger.
Yeah, I
I'm not talking about openers. I'm talking about the people that are
garage door opener. How did I come up with this number? Okay, how do you come up with the garage door opener with this number? Good point. For motors, guys, garage door opener, garage door opener. Okay, here's what I want you to know. For garage door opener and all the motors, here's what you're going to be doing. You're going to go to the code. You're going to find the full load current under the voltage. Like the voltage for this one is half horsepower at 120. Multiply the amp at 120. Multiply it by 120, and that will get you the 1127. If you go to the pool pump, if you guys go to the pool pump, sump pump, did they have a sump pump? Sump pump is there, like sump pump. If you go to the sump pump, is given as volt amp. If you go to the swimming pool is giving at 3 horsepower. If you take a 3 horsepower, guys, find the full load current for 3 horsepower from that code, from Article 432.48, the table. Find the full load amp, multiply it by the voltage. That will get you that number. Let's do this one. Can I do the pool pump just to get you where we got these numbers? See if we can get it right. Take this. I'm going to do the pool pump only. Pool pump. The pool pump, guys, I'm giving you a pool pump of swimming pool pump of 3 horsepower at the voltage is 240. Okay, so Chris, how do you convert horsepower into volt amp? You're going to go to the table. Let's go to 430. Can you guys go with me to 430? There you go. We're going to go to, this is single phase motor, so it's going to be full load current in amp, single phase alternate. Okay, 430.248. So you're going to take the 3 horsepower at 240. You're going to take it to table 430.248. If you guys go there under 240 volt, if you go there to find the full load current for 3 horsepower, 17, everybody got 17? You're going to come up with a 17 amps. 17 amps. 17 amps. Everybody came up with 17 amps, guys, for the sump pump? Okay, so step number 2, you take, so that's the full load current. Step number 2, you're going to take the 17 amps, multiply it by 240, and what do you get? Calculator, handy. 240 times 17, 17 times 240 equal 4080. 4080 volt amp. Now, Chris, you can make the Excel sheet do this calculation for you. I have no problem. Making Excel sheet does the calculation for you, or you can do it aside and plug it in there. So I'm going to go back to 4080. Do you see that? Oladipo, where I came up with this number? I think is it the same number or a different number? Let's go 4080. Let's go back. And then 4080, go to Excel. This number should be then, for the pool pump, this number should be 408. What do you say? 408.
48.
4080. It's going to be 4080. Okay, there you go. It's going to be 4080. Okay, thank you, and that will calculate it. Let's do that one for the garage door opener. For the garage door opener, let's change that one. Let's go for the garage door opener. Do it for the garage door opener. For the garage door opener, my friends, just quick. Garage door opener. What's the garage door opener? The garage door opener is half a horsepower. Garage door opener. For the garage door opener, I have half a power at 120, half horsepower at 120 volt. So if you take this one to the same table, 430.248 under 120 volt. If you guys go there, it's going to be 9.8. Thank you. It's going to be 9.8 amp. Take the 9.8 amps, multiply this one by 120. 9.8 times 120 came up with 1176 volt amp. Any question, guys, about this? Now you can make Excel pick the full load amp from the code and do this calculation for you. Be my guest, or you can plug him in. You do them aside and plug him in here. So 1176. Let's go back to my Excel sheet and plug him into here. 1176. Cool. Any question, guys, about how we came up? Thank you. All of you, makes sense? If you have a horsepower, you need the full load current from the code multiplied by the voltage. They'll give you the assumption. This is big deal when we go to commercial, guys, because the commercial, I'm going to be giving you horsepower for the air handling unit and all this good stuff. So how are you going to find the volt amp?
Well, the nameplate says full load amps.
You use the code.
What does it say that you have to?
The only place where it says you need to use the nameplate as the full load current. How do you size cables?
Okay, I mean, this 432.48 says full load current.
Okay, full load current.
And the nameplate says full load current.
If it want to say the nameplate, it will be this. It will say the nameplate full load current. Look at under 430.32 for the overload. See how the word that they use, they say nameplate full load current. Unless they say nameplate full load current, you're using the code full load current. There's somewhere, I'll show you where it says the default is the tables.
I mean, there's a difference between sizing the breaker and sizing the overload, correct?
Yes. Yes. But unless it says nameplate full load current, you're going to be using the code full load current. Okay. Any questions, guys, about all these? Cool. All right. So what we did here, we took the largest of the two, multiplied them here, and then we added the two steps. Step 14, line. So we're going to go. We're going to add these steps. This is coming from, where is this? Is 77. Where are we here? Grand total. Okay, we don't want the grand total yet. So this is full load current. And where did we carry them? Where did we carry this step? What's this? Okay, get this one. Okay, I'm going to see where. Okay, this is carried from here. Okay, this is carried from all of them. Step H77. What is that step H77? H77. Okay. Okay. 914. I need to do one little step here, guys. I need to make this step equal this plus I want to add the full load current. Okay, I know what the issue here. You're going to take the full load. We need to make it add all these together. So I'm going to add these. I'm going to have a step here that take equal sum. You guys know how to do the sum all these together. Enter. So that will sum them all. What did I do here, Chad? Did I? Sum, open parenthesis, perfect. There you go, and enter. So that's I'm going to say this is sum of them, all of the stuff above. Then, so we sum them up. This one, I'm going to call it total sum for this step, and I'm going to make it equal this baby plus this baby. Enter, right? And I make it red. And then the last step here, I have to modify it. So this came up with, I need this one actually to be the total. This. Enter. Okay, so where is this coming from? 77. This will grab the 77, which is 77, which is that major total that we got. And then it align it with step line 14, and off it goes. Okay, so that's the grand total for everything else. There's one little problem. My heater is cut left out from the grand total. I want to go take my heater that I added, guys, cut it from here, see if I can drop it so it could be included in the grand total. All right, good. I cut it. So that will make this one actually 14, like we said, 14 one step. That's my heater. It's right here. So the only thing I need to do now is to make this equal this plus this. 77. I need one more. Add my heater because Chris made me do so. Add my heater. There you go. Okay. So this one will equal the total. This cell is screwed up. So let's say I need this equal this plus this. I know that for fact. And I'm going to go all the way plus this cell. Now we're cool. So grand total. Okay, makes sense, guys. I took my grand total is adding the baseboard heater, all the motors, and all the total at the top. 79200. Any question about that? You can do it in any way, shape, or form you like. So this one would be step number 3. Okay, 77. I don't know why we did them. This is the grand total. Step number 13 and 14. You know what I'm going to do? Step number 13 and 14. And I want just to make it for me, and you guys will do it. This will be step number 14.1. Add up. And I really care less about. I'm going to make this cell about all this. Here is really meaningless. Okay, and I'm going to make this one right here, copy, and bring it right into here. Paste it here, and delete the stuff. Okay, I cleaned the step, the grand total, guys, and I made it just the sum of 13 plus 14 plus 14.1 in my sheet. In your sheet, it will be similar. And here's the step 13. Can you guys see step 13 right here? That's step 13, the sum of step 13. Step 14, the sum of step 14, and sum of step 14.1. And I added them all at the top, bottom. Any question, guys, about the sum pump? Yes, sir.
I know you and Chris were going back about the cooking and stuff, but is there a reason, is there a difference where you added it? Because you're going to come up with the same total.
You're going to come, yeah, you're going to come, you should come up with the same total. The only difference is, if you do the way I did my math right now, do the maximum. If I put the heater here, it could, well, it's in this, if the heater was more than this number, it picked the heater as your largest motor. You know what I mean? Because the way I did my math, it really, if you did your math different, doesn't matter. two things. Number one, the way I did my math, it could screw up my math. Number two, it's really nice and from an organization point of view. If they're not a motor, don't put them on the motor. So you know what type of load you have. Especially that will groom you guys to the commercial industrial. In a commercial, we're going to have HVAC pumps, motors, and we're going to have owner equipment motors. Two different type of motors even. So organize the load based on the type. Any question, guys, about the 1,000 that we came up with? Chris, did you come up with something similar?
I haven't done yet.
Huh? You didn't do that?
I haven't put the input.
Okay. Yes, sir.
How maximum that money give us a copy of this amended?
Amended one? Okay. Shall I give you a copy of the amended one here, guys? After we do? That help? Okay. That will help a little bit. Okay, go. Let's continue, guys. Can I continue? Can I have your full divided attention or full undivided? Any question about the 1,160 volt amp? Now I need to size. Now I take this number here. Can you guys see that? And I divide it by 240. Chris and Nick, my friend, why do you think 240? Because the system is 240. And I came up with this amps. I came up with let me just say, let's round up. Oops, round up to 100 amp. Okay. I came up with 417 amps. 417 amps. That's how I'm going to design my service based on 417 amps. And then I went down here, and what do you guys think the next standard overcome protection device that I can? From 240, I'm going to size based on 240. So I'm going to go, do I have 450? I don't think we have 450. Do we? Always get confused between 450. Oh, Chad, do we have 4? Yeah, we have 450. So the next standard overcome protection device, Chris, my friend, is what? 450. So my panel will be 450 amp panel. Okay, right in here, could you please use your, give yourself kind of a note right here. This will be table 240.6. So don't get confused. All right, so this is my major baby. So what panel size do I need for this building? 450. Any question, guys, about this? So what did I do? I took all this, divided it by 240. I came up with 417. My next overcome protection device is what? 450. So my panel is 450. My panel is 450. Did you guys come up with, Rob, did you guys, and Phil, did you come up with, or you didn't plug them in yet? Okay. 450. Any question, guys? So what size panel do I have? 450 amp. Done. Done with the panel. Okay, I'm going to skip the neutral conductor for a second. I'm going to skip the neutral conductors. Okay, well, let's go size it right away. Let's go talk about the neutral now. Any question about the phase conductors, guys? Any question about the phase? So what size conductor do I need for this building? Later on, we'll size it based on 450. Any question about the size up to this point? Okay, let's go to the neutral. For the neutral, guys, for my neutral conductor, I need, for neutral conductors, you only count, for neutral, you only count the line to neutral load. Only the line to neutral load. So, the first thing is going to be based on this H31. Where is it? H31. Can you guys see why I grabbed right here? I grabbed line 7 or step, is that line 7 or B step? I'm going to go, so I grabbed this number. Can you guys see this number? I grabbed the demanded lighting, general receptacle, small appliances, as well as laundry. All this after you demand it, that will count towards your neutral. That will count towards your neutral. Any question, guys, where this number came from? Can you guys see this number came from H31?
On the PDF, we can't.
Yeah, you can't see that one. That's why I want to make sure it's 31D 6D. I'm going to go call this one in 6D. This one is coming from Okay, come on, Jan here. 6. Okay, this is 6. I'm gonna call this one 6. Line, this is coming from step 6. D. That makes a little bit of sense here. 6D. Okay, any question where this one, guys, came from step 6D, which is if you can go all the way up to step 6, item D, it added him all the way, 1140. Is that enough info to give you step? Here's a step 6 and line D right here. Okay, so that's this number. I hate calculating neutral because I always like full neutral. Okay, the second thing, guys, the second thing is we need the range. The range, if you go to step number 7, this should be slightly different. I'm going to go to step number 7, all the way to step number 7. Okay, right here. So can you guys see that? The demanded step number 7, right here. Step number 7, everybody's okay with that? I got it from the range, step number 7. And the code says, guys, the code says for range and dryer, you take the demanded load and multiply by 0.75. Where did I get this number from, Chad? Right here. If you guys look at these, if you look at 22.61b, it will tell you for the ranges and the dryers for neutral, you take the demanded load and you multiply it by 0.75. The code tells you in 220.61b when you read it. Okay, the same thing for the dryer. This came from B. If you guys look at this one, this coming directly from 35. Right here. Where is it? Right here. Can you guys see that? For 2 dryers, came from item number 8. Is it item number 8 and item number 8? Okay. Multiplied by this number equal this. All right, and include only the 120. Now, for line 11, line 11 is weirdo. Line 11 is weirdo. If you guys go to line 11, I'm going to go all the way to line 11 or step 11. For step 11 here, the only equipment that you need to add here is only the 120 equipment. And that's where it's kind of interesting. For step 11, for the neutral, the only equipment that's going to add is anything that's burning at 120. Take this. Water heater, drop it, because it's not running at 120. Dishwasher, included. Garbage disposal, included. Microwave, included. All these are included except the water heater. Except the water heater. So that's kind of where it becomes funny. How are you going to do this math? So for this one, guys, I'm going to go and make, I'm going to go actually copy the stuff that I did and make it easier. Copy this stuff right here. It's easier. Do it this way. Copy this step and take it down for my neutral. Take it right into my neutral right here. Paste it. There you go. Here's my neutral. And then I'll delete the stuff that doesn't count. So take this. How many do you guys think the water here will count? No. Why? Because it's 120, not on the neutral. So what do you do here? You put 0. Yeah, 24 is not counted. There is no neutral in that. So you don't for neutral. Okay, everybody see why I copied this one, guys, here, and I took the 5,000 for the water heater and put 0, because there's none of them will be seen by the neutral. They're running at 240. All right. How about the dishwasher? Would they be seen? Yep. How about the garbage, the microwave? Everything here will be seen, no problem. So that will be seen, no problem. And then I have to apply a demand factor for them. So total them. I need to total them. So when I come to the neutral here, I'm going to go just arrange this slightly different here. Arrange this slightly different. Come over here. I'm going to say volt amp, and I'm going to make total these. So this will be equal sum open brackets, and grab all these, enter. So let's sum them. And then this one, guys, will take the largest. No, we're going to take, if they're more than 3, for this one, if they're more than 3, we're going to take them. So this cell should equal this cell. If there are more than 3, more than, what's that code says, if they are more than 4, fixed in place. This is load more than 4. Okay, if they have more than 4 fixed in place, you have to derate them. So if you go, the same thing for the neutral. Do I have more than 4 equipments, guys?
4 or more than 4?
4.
Is it? Let me see what the code.
More than 3.
Okay. Fasten in place electrical equipment for dryers, blah blah blah. 53. Article 53. 220.53. 220.53. 220.53. It says it shall be permissible to apply demand factor 75 to nameplate blah blah load of 4 or more. 4 or more. If it's 4 or more, you're going to apply demand factor. Let's go to the neutral. Here's my neutral. We already applied it on the phase. For the neutral, do I have 4 or more? Do I have 4 or more? Yeah, you have 16 here. 4 plus 4 plus 4. Right? So you're going to apply demand factor. So I have, then this number should equal this. Oh, 4 plus 4 plus 4 is 12. Thank you. Yeah, but it's more than 4 though. 4 plus 4 plus 4 plus 4. Then we need another 4. Okay, so my intention is there more than 4 or more, right? So you multiply by 75. Any question, guys, about the neutral? The same. We're doing the same calculation for the neutral now. The same calculation. Okay, so we got the step for the neutral. Calculate all these. Okay, line demand for these. Okay, so what do I need to do also to make these? So we got these. We need to add these. Make sure that we are going to add these two ones. So I'm going to make them red because I need to add them. We add this one. Okay, now let's go to the motors. For motors, guys, we're going to only account for motors that run at 120. How many motors run at 120? I'm going to go grab the motors again, the way I did my motors. I'm going to grab this and really copy it. I'm going to grab the whole item here. Insert. Let's do this. Let's insert these. Copy. Let's go insert all this under motors. I'm going to insert them right in here. Insert copied cells. Okay, so I inserted them, and I'm going to go delete the junk that I did before. Okay, done. Okay, so here's for the motors, guys. I want you to look at with me. Does the sump pump run at 120? Sump pump 120? 0. Does the exhaust fan run 120? Yes, leave it. Exhaust fan, yes, leave it. How about the pool pump running at 120? 0, yeah. And how about the garage door opener? 120, leave it. So I lift the stuff that only runs at 120. Everything 240 will be deleted. Some pump is run at 120, isn't that? Some pump, no, some pump is actually run at 120. So some pump I need it. There you go. Okay, so what I did, guys, I took all the motor steps and I just, anything that's running at 240, I put 0 next to it because it's not going to contribute to the neutral. It's not contributing to the neutral. Does that make sense? The same step. Anything that's not contributing to the neutral, anything 240 is not going to contribute to the neutral. So it's going to be 0. Did I do it right, Nick? Sump pump is 1, exhaust fan 120. bathroom fan, pool pump. Oops, pool pump is 240. Drop it. Garage door opener. Then you do the same thing, guys. The same math is right here. You add them up and you take the largest motor of this system. Okay. The only thing that we're missing here, Chris, because of you, my friend, is the fixed heater, the heater. But no, it's nice because it makes it better actually. So if you like, so the pool heater, do I need to add the pool heater on the neutral? No. Why? It's running at 240, so I really don't care about it. Okay, so add all these steps. Let me see what we accounted for. We want to take this here to grab it on here, so I corrected that one. Total sum of this plus this. This is to size and neutral. Okay, I'm going to go actually do it one more time. So this is going to be this step here for the motors. I know that for a fact. And then it will be all these and plus this is already demanded 25%. Yeah, the sum total, yeah, this is demanded plus line plus this, and we're going to go to this plus this plus this. There's nothing in here. Okay. All right, so I totaled for the neutral, guys. Can you guys see that? Does it make sense? Let me do it. Guess my math again for the neutral. I added for the fixed in place appliances. Yep, done, Chad. How about line D for motors? Fixed in place for motors is there. And also for line 8 and line 7 and line 6D, everything is there, right? So I accounted for all my neutral load. Then when you account for your neutral load, guys, you carry it here, you divide it by 240, and it will give you 225. So what's the amp for this baby? 225 for the neutral. Oops, no, Chad. There you go. So my neutral is 225. My neutral calculation came up with 225. Any question, guys? Any question about that one? I'll PDF this one and give it to you one more time, better in a better format. You really, the neutral, Chris, you're going to ask yourself the same calculation that we did for the phase, except anything 240 out the window. With exception for ranges and dryers, they allow you, because they have a neutral in them, to take 75% of their demanded value. Done. So I have my neutral. I have my neutral 222 amps, and I have my phase 450, and I need to go size the conductor. So let's go size the conductor. Any question, guys, about the amps that I came up with? 225.
If we use the example in NXD for multi-dwelling, do we come up with the same number?
Okay.
That's a question.
Oh, you should. But do they have a water heater though? Make sure they have the same equipment that we do.
Well, I'll just follow
Yeah, follow the equipment. Yep.
procedure.
Yep. Any question, guys, about this for the neutral? Okay, the grounded conductor. Now sizing the grounded conductor. I'm going to make this cell actually. I go size based on the overcome detection device. Minimum circuit, conductor for the neutral. I want to go make this cell, pick this one here, enter. So let's go back to, so how am I going to size the overcome detection device, guys? I'm going to size it based on 450 amps. 450 amps. You're going to go to table 310.15 B6 or table 310. Table 310.15 B16. If you go to any of these tables, enter. If you guys remember, 310.15 B6 is actually should be B7 here. Now it's changing the code, B7. I thought I did that one. Okay. 310.15 B7 it's limited to how much? It's limited to 4,400. Can I 4,400? Can I go use it higher than 400? No. So where do I need to go then? I need to go to 310.16. So if you guys go to 310.16 and size me a cable, will you? 310.16, 310.15B16
Under USE,
under
what do you
US.
need the cable, the insulation type, or do it?
The insulation, we're using, let's assume that we're using an insulation rated for 75. Here, Chachan.
USE, underground service entrance cable.
Yes, we'll do it. So if you go, I'm going to go to any 75, rated 75. So I have 400 guys, 400, 400, 400. I need 450, 420, 450. I need 700 KCM.
And wouldn't it
Or
be
six.
aluminum with the
Why? Could be.
console?
That's all right. 700. So I need to go 700 KCM. 700 KCM. Okay. What I did, guys, I took the 450 and I sized my cables for it. I sized my cable 700 KCM. You can parallel these. You can parallel these. No problem. Go ahead and parallel them. But I sized based on 310.15B16.
Wouldn't the utility provide this anyway?
Not the service entrance conductor. They provide the power up to the meter, from the meter end,
So this is from the meter.
yeah,
to the-
from the meter end to your building, that's your service. You provide that one. Any question, guys? Why didn't I use 310.15B16, 310.15B7? Because we're higher than 400 amp. 400 amp higher than 400 amp, you default to 310.15B16. Okay, neutral. Here's my neutral. I'm going to go size my neutral. You're going to size your neutral based on the amps that you do it to 225. So if you guys go to 225, the same table, 225, 225, all the way to 222 actually, 4 aught. So my neutral here will be 4 dash aught. I don't know if we can do that one here. Okay, 4 aught. My neutral will be 4 aught. My neutral conductor. My neutral is based on 222. 222. 4 aught. There is one issue with neutral. We'll talk about it in a second here. See, we might go higher than 4 aught. Any question, guys, about sizing the phase and the neutral? Sizing the phase and the neutral.
You didn't want to use cable B7 for neutral?
You use table B7 if you use... No, I wouldn't. Because I sized my service based on 310.50 B16. If I size my service based on 310.50 B7, then okay. Otherwise, you undersize your neutral. Any question, guys? 700 KCM, 4 aught. I'm going to check one.
So this, we'll use the same format and formula for doing the individual units as well as the central, the timing thing.
Absolutely. I'm going to do one more thing, guys. I'm going to just drag certain things under this is for the main panel. I'm going to drag a couple of things, and then you will continue. Just show you how it's going to go translate into the apartments. Okay. Then when you go down here, when you guys go down here, you're going to size the grounding electrode conductor. You're going to go to 250.66. Let's go to 250.66, please. 250.66 and size me an equipment grounding conductor. That's the grounding electrode conductor. Grounding electrode conductor 250.66 right in here. And I have 700 KCM. My 700 KCM will give me 4 aught. right? Can you guys see that? For 700 kcm over 600 through 1000 4 aught. So this baby is going to be 4-0, 4 aught. Then you guys will do the rest. Then you're going to do 4 aught. Then you're going to go carry the 4 aught. How many conductors of 4 aught do I need? I need 2. How many of number 1? I need 1 neutral, 2 phases, 1 neutral. Make sure you go find the cross-section area for them. These will be different. You're going to find the cross-section area for them, and then you need to size the conduit. And I'm going to get rid of the conduit inch here. It's going to equal this. So you need to size. Let's use a PVC. We're coming from underground. Oops. Let's use PVC here.
40 or 80.
PVC 40. We're using PVC 40. And I'm going to get rid of the size here. I'm just actually put the PVC right in here. PVC-40. And I'm going to make you guys do the size here. Actually, PVC 40. Any question, guys? So that's it. Yes, sir.
For your conductor size,
Yep.
I don't know if I'm looking at it right, but I get 2
Which conductor are we talking about?
the grounding.
The grounding electrode. Grounding electrode, they have 700 kcm. 700 kcm over 350 through 600. Oh, yeah, copper, 700. That will give me 4 aught. That will give me 2 aught. Where did I get the 4 aught from? I was looking under aluminum. You're absolutely right. This one, I was looking under aluminum. This should be 2 aught. Thank you. One of us is awake here. Okay, 2 aught. You got it. So I was looking under aluminum. We have a copper. So 2 aught. So I have a 4 aught neutral, a 2 aught grounding electrode conductor, and a 700 kcm for this apartment building. It sounds a lot, guys, 700 for an apartment. If I just shift it slightly to 400 amp panel, if you shift it to 400 amp panel, you could have gotten away with 600, probably. Yeah, 400. You could 400. You could have gotten away with 400 kcm if we made our panel 400 amp panel, but it's not 400 amp panel.
What would you use for insulation size in your combo?
I'm assuming there's going to be THHW. Any 75 rated cable or higher.
It has to be wet.
Wet location. Any question, guys? Any question about this? So we took the whole building and we sized it for the building. Chris, my friend, can I have your attention, guys, for 1 little second here? If you look at the neutral conductor, can you guys see it right underneath the neutral conductor? It tells you no matter what you come up with neutral conductor, it cannot be less than the grounding electrode conductor. If you guys read through here and go to 250.66, the neutral conductor must not be smaller than the grounding electrode conductor. And who tell you this? 250.24C1, it will tell you your grounded conductor under no circumstances shall be less than the grounding electrode conductor. So your neutral, under no circumstances, your neutral can be less than 2 aught. What's my neutral now? 4 aught. Am I good? Yep. So please pay attention. Most of the time you guys end up with a neutral higher than the grounding electrode conductor, but you're going to pay attention to the grounding electrode conductor too. Your neutral under no circumstances can be smaller than the grounding electrode conductor. So the 4 aught that you got for neutral, if it was 1 aught, then I have to go to 2 aught. Rob, my friend, reaching this point, can you size the conduit? You guys have my calculator. So you get the cross-section area here and you size your conduit based on PVC schedule 80.
80 or
40. 40.
your neutral is 2 aught or 4 aught?
I'm sorry, we made a mistake. The neutral is 4 aught. The grounding electrode conductor is 2 aught. Any question, guys? We sized it for the whole building. Now, moving forward, go.
4 aught larger than 2 aught?
Yeah, but that's what we
The
want.
grounding conductor have to be greater than?
The neutral conductor has to be equal or more.
Oh, okay, yes.
E-
Neutral has to be greater than. the-
Yes, gotcha. That's all right. Okay, moving on, guys. Here, now we're going to go to the apartment. Did you guys see what we did for every? Now this is where you guys going to come and do your magic to make this happen. So now I'm going to do very quick things. Show you what I would do. Ashley, you can take this stuff and copy it 3 times. One for the main, one for the largest apartment, and one for the common and color ID, and change certain numbers in it. So 3 files. We used to do that one in the past. I think the better way is to add another column to the side. You guys have that. Here's my main panel, all the size for my main panel. Now I'm going to go right under all the apartments based on the largest apartment and size it. So this is what I'm going to do. This needs a little bit modification here. So what I would do, and you guys are going to modify it. I'm going to take my volt amp here. I'm going to take I'm going to make this one my square foot of my building. So what's the square foot of my building here? The square foot of one apartment, the largest, let's say 2,000. One apartment, the largest, 2,000 square foot. I'm going to multiply it. I'm going to make this one, look at what, I'm going to make this one equal this 2,000, Chad. 1, 2, 3. Oops, not here. 1, 2, 3. 2,000. And I want to make this cell, and you can make it any way you ship. I want to make this cell equal this square foot of this building multiplied by, you guys remember what the 3 volt per amp square foot multiplied by 3 equal. So this number here is the volt amp for one single apartment. Cool? Done with that apartment. Let's go to the second number here. The second number here is going to be how many, this is for branch circuit, okay? Great. So how many branch circuits do I have? I have in one apartment, small appliances branch circuits, I have 2. And what's the volt amp for each one of them is 1,500. So actually I'm going to make this one equal 2 of them, right? Multiplied by, let's see if I can grab 1,500, multiplied by 1,500, right here. Multiplied by 1,500, 1,500. Why 1,500? Because that's from the code, volt amp. So this is the small appliances for the small appliances 2 circuits for an apartment. Let's keep going down. See how we're going step by step, guys. This is for the laundry, right? If you guys move slightly here, it says for the laundry. For my laundry, though, what did I do here? Okay, so ignore that one here. The stuff here. Let's ignore that. Okay, so let's go for the laundry. For the laundry, how many laundry do I have in the apartment? 0. There's nothing in the apartment. So put 0 here. Multiply it by, so I'm just to do the math, equals 0 times 1,500. And what do you guys think the answer would be? 0 volt amp. Volt amp. But what helps me, guys, as I go through your little calculation, I'm looking at the laundry circuit. I know there's 3,000 accounted for under the building, but under the apartment there's 0. And why 0? Because the apartment panels will not see the load that's coming out of the laundry. Why? Because the laundry is set where? In the common panel. We're going to be accounted for it right here in the common panel. Okay, so let's go, and I'm not going to do all of it, but I'll give you guys the hint how we continue doing it. Okay, let's go to the, then sum them. You guys see that number here? So this one, where am I here? I'm going to go sum this number. So I'm going to change this one to volt amp, and I'm going to make this number equal sum open brackets, and I'm going to go grab the total here. I guess you can grab them all, or okay, I'm summing them. Make sure you delete this. So I'm summing it, and also when I sum it, I want to give it a color, so I know. Oops, I don't want to color. I want to give it a shade. I was doing red, wasn't I? It doesn't print good with red. Green. Let's do green. Oops. Okay. So I just a visual indicator for me, guys, that this is what I need to do. Then you need to apply the same rule here. The first 3,000, the first 3,000. Do you guys remember that first 3,000? I'm going to do it in one lump sum here because you guys are cool. It's already here, so I'm going to do it in one lump sum. So how am I going to do that? Look at that. I'm going to make this one equal 3,300. I mean 3,000 plus this cell minus, I'm going to put my brackets. You can do that one in one step. Minus 3,000. Oh, yeah, 3,000 times what's the multiplier? 0.35. 0.35. Right on the cell. Can you guys see what I did? All this stuff that I did in multiple cells, I don't need to repeat this. It's already shown here. So what I did, I said this cell will equal 3,000 plus the number that I came up with here minus 3,000 multiplied by 0.35. I think it will. The math will pick it up. Here you go. All in one. This value all in one. If you guys look at the top, it's equal to 3,000 because that's by the code, plus the number that I came up for the apartment, the 9,000, minus 3,000 multiplied by 0.35. All in one formula. What we did in the apartment, in the building, we split them just for you visual to see it. In the apartment, there's no need for me to split them. I know how the math goes. You can go design that little math, that one cell, plug it in there. So that would be, I'm just for me visual, that would be my red. So I know that this is this need to be carried all the way through. No fail. Okay, I'm going to do a cooking equipment quick with you guys here. Okay, let's do for the ranges. Volt amp is volt amp. Okay, for ranges, how many ranges and what's the volt amp for the ranges? Okay, let's start the ranges. How many ranges do I have? I have only one range. Okay, so here's my actually I can carry this one. That's just 8,000. What's my, okay, now I have one range, 8,000. So I'm going to make this cell equal this multiplied, what's my derating factor for one range? The best way to do this one, because I already have the range here. I already have the cell range. So here's what I'm going to do. The derating factor for one range is 0.8, guys. So if you make this cell equal the 0.8 multiplied by, you're going to go all the way to the range size that you have right here, equal. So where the heck did the 6,400 came to be? This is from the 0.8, the derating factor for one range, multiplied by the 8,000, which is only one range they have. Because we're looking at one apartment. And make this red because you need to carry it. Okay, let's do the, what's the other one? The dryer. I know, do the dryer. Now the dryer, guys, I know there's only one dryer. So I'm going to say for my dryer here, I'm going to make this cell equal. Do I need to derate? We didn't derate for the dryer. I'm going to make this cell equal this cell, right? Because 5,000 for one range, okay? Multiplied by whatever demand factor I have, which is 1. So take this, here's 1. What did I do? Okay, here we go. This is 1. Let's do one more time. Okay, equal. See what I did? I made this cell equal the one, my demand for one dryer is 1, multiplied by 5,000 for a dryer, and that will be equal 1, and then add it here as a volt-amp. Volt-amp, done. Here's apartment number 1 for apartment done. Yes, sir.
I think the apartment doesn't have a dryer of its own.
Oh, thank you. So the apartment doesn't have dryer, Chad. So what do? You put 0 here, and guess what you get here? 0. The reason why you add it though is what if the apartment has a dryer? Then all what you have to do is just put a cell here, 1, and off it goes. Good point. Any question guys about this? Let me do the second step, and you guys get the rhythm of it. I'm gonna make do we have ranges? Yeah, I'm gonna make this one under this. Okay, so let's see how many air conditioning do I have? 1. This will be equal this multiplied by the size of the air conditioning equal. If I drag these, oops, yes. If I drag this back down, it will do, I don't know what it would do, do this by this, which is I have 0 here. Okay. And volt amp. Okay. So anyway, it doesn't matter here the way we do it, guys. But you have to pick the largest of the two. You're gonna look at them and pick the largest of the two. In my case, I know the 4,000 is the largest. Off it goes, and here's I carried the 4,000. Oops, not with this. I hate doing it with this. Okay. Then the total. I'm gonna do the total. Delete this. I'm gonna do the total. This step just to follow what we did. This is totaling everything, so it equals this plus this plus this one. So I carried all these, this cooking equipment, all the way to the derate, to the derating and small appliances. This is what the derated value, and enter. So that's my value for this step. That I'm going to make it yellow. Oops, not this. Make this one yellow. Go down here and get this one into no fail. Okay, so that's the whole, that particular, all of them added together will give 15,500. Do you guys see the rhythm of what we're going to do? I'm not going to do it all. You guys are going to be doing it, but do you see where we're heading? And you keep going down, down, down each step, how to size all of them. Now we go to the ranges. I'm going to do this one because it's kind of interesting. For motors, you're going to be careful what's in and what's not in that building, and when you demand it. So what I'm going to do, I'm going to go here and pick this equal for this step. This equal. Okay, ask yourself, what's in the apartment? Do I have water here in the apartment? Do I? Water here in the apartment. Yeah, it's fit from the apartment. Equal. So I carried the water here. Then maybe we should do it here. This equal this. I carried the water here. Just carry them. I'm not doing anything here. And then if I were you, I will ask myself, do I have a dishwasher in every apartment? Yep, Chad. Carry it here. Do I have equal? Do I have full garbage disposal in every apartment? Only one. Yep, Chad. And equal. Do I have, what else do I have? Do I have a microwave in every apartment? Yep, equal. So I have all of these. So I want to do 2 steps here. I want to sum them and take the largest of them, multiply by 0.25. So you can do this one in so many ways. Okay, we're doing it the largest, and no, we're taking. Okay, I'm going to do it in add them up here. So the way we did them, we're going to add them all up here. So okay, I'm going to add them up here. Equal. sum, open brackets, and I'm going to stop guys in a second here. You get the rhythm of it. You got these, add them all up, and then I need now, do I have 4 or more? Do I have 4 or more? Do I have 4 or more? Yep. Do I have 4 or more? Yeah, I have 4 or more. So I need to apply demand factor for them. So I get then this equal this. 0.75 electric space. Okay, so this will be equal. Just trying, where am I in the line? Total computed load. Yep. Demand. Yep. Here you go. That step. That particular step. This equal this number multiplied by the demand factor right here. Off it goes, 75. And make sure, my friends, is go to highlight this one in red, because that's the one they're going to be, oops. Now this way, we're going to go highlight it in red, because that's what we're going to be carrying downstream. And of course, if you have to change this one so you can see it, red and red. Okay, so what I did, I carried all the apartment fixed in place appliances. If they're 4 or more, I apply demand factor of 75. And that's the step that I'm going to do. I trust that you guys will go down and do the same thing for the rest of them. Any question? Any question about this one, guys? Now, if you decided, say, Chad, I'm going to do one for the whole building, copy it 3 times and make it and just adjust it, be my guest. That's what we're doing in math. Okay? Any question, guys? Okay, so I'm going to stop right here. I want to remind you guys, continue, that you need to go back again and do the same calculation for the house panel. Now for the house panel, you got to be careful, guys. For the house panel, what's the square foot for the house panel? The square foot is just the common hallways, as well as the laundry area. That's just a square feet. And then you keep adding. Does the common panel has 2 small appliances circuit for the kitchen? No. So what do you put? 0. And you keep picking up the stuff that's on the panel, not the ones that's not on it. Any question, guys? That will summarize the whole load calculation, what you guys are going to be doing it. So you're going to end up with either 3 sheet or 1 sheet like this that represent 3 things. You guys want me to PDF this one, send it to you? PDF? I don't want you to be looking at stuff that's not there though. Okay. So that would be, and you can see the I don't want to confuse you with the stuff here. Okay, let's save it, continue.